Hello, today I'll tell you about the 4-electrode polymer electrolyte membrane conductivity head that enables you to make PEM conductivity measurements in the ProboStat. Polymer electrolyte membranes, also known as proton exchange membranes, are the successful electrolytes in PEM fuel cells and electrolyzers. There are new developments in this area, like the high temperature PEM membranes made by, for instance, acid-doped polybenzimidazole and other polymers, or using composites with ceramic fillers to increase the temperature of these polymers. We also have the development of anion exchange membranes instead of protons. When you test these membranes, they have high conductivities, and this requires preferably 4-electrode in-plane measurements. And there are many commercial fixtures available for this, for instance, from Scribner and other companies. Here you see one of them that we also use in my laboratory, where the membrane is fixed and pressed with these screws in between 4 electrodes. And this is placed inside the sample holder, and the electrodes are connected through here, and the whole thing is mounted in a PEM test cell that is supplied by Scribner in this case. This allows you to supply controlled humidities, high relative humidities, meaning steam at high temperatures. And you can also heat these up to elevated temperatures, like typically up to 150 degrees. So these work well and are well established for testing PEM membranes. And now we have also developed this 4-electrode head for the ProboStat, for those who have a ProboStat. Here you can see the head where you have terminals and 4-electrode wires here, in this case gold, and in this case of platinum. And here you see this head mounted on the top of a support tube. It fits to the support tube of a ProboStat, and electrode connects are made down to the base unit. Here you see the whole thing mounted on the bench with the spring load of the ProboStat holding the whole thing down. So this design has 4 replaceable wire electrodes, like you see here. The standard supplied by us is gold or platinum. And these are then contacted by 4 electrode connect wires here on the sides, on this side and the other side of the head. It has a peak construction, which means that the materials here can tolerate 200 degrees long term, or up to 250 degrees on a shorter term, which is higher than most commercial test systems otherwise. As I said, this fits onto a standard ProboStat, 20 millimeter outer diameter support tube. It has a perforated top plate that we press down using the spring load. This allows equilibrium with the atmosphere via the perforation here. And it makes contact, it forces contact between the polymer film and the electrodes here by using the force of the standard spring load. The temperature can be controlled or monitored using a thermocouple here on the outside of the head. But there is also a hole into most of the head on the inside, where also the inner thermocouple of the ProboStat can monitor temperature very close to the membrane itself. It stops just under here. In order to do these measurements on polymers, you need a few other things. So first of all, you need a ProboStat base unit, which has a 20mm support tube, an outer tube to contain the atmosphere, a spring load, and a thermocouple. These are standard things in a ProboStat. If you want to measure with high steam contents in the atmosphere, you may need a heated base unit, a special ProboStat with a hot feed through of the gases. You need to control temperature. For this, you can use a furnace. For instance, there is a Chinese low-cost furnace that can control temperatures very well, down all the way to room temperature. Or you can use a heating mantle from, for instance, Glasgow in the US for controlling temperatures over up to a few hundred degrees. You need to control the atmosphere. You need to control the humidity. So you can do this by sending air or another gas through a simple bubble humidifier. You must take care to avoid the pressure buildup in such bubblers. Or you can, for instance, get a humistat from Norex, which is a machine that can mix two gases in any ratio, and in addition add from 0 to 100% steam through a heated tube that goes to the ProboStat. You need instrumentation. You need something that can measure with a 4-terminal setup. This may be a DC instrument or an AC instrument like this impedance spectrometer here, for instance. DC and AC have different advantages and challenges that I will tell you about now. Before that, let me just also mention that in-plane measurements of films, like this setup here, have certain features versus through-plane measurements, like this one here. So in an in-plane measurement, you can do a 4-electrode measurement. You supply the current here and here, and you measure the voltage here and here. This is a very well-controlled geometry, and it has several pros, like 4 electrodes eliminates in principle the electrode impedance. It has an accurate geometric factor, and it allows you to measure with a quite convenient conductance range, so that it's not a problem with current collection, for instance. On the other hand, if you do DC measurements here, the electrodes may be quite blocking. That means that quite little current goes through, and there is not so much voltage then to measure on here, so you can get quite noisy measurements. And also, DC measurements may favor some carriers over others, because the electrode reaction here may be easier for electrons or protons than, for instance, other ions. So if your membrane is a mixed conductor, you may not get the fully true picture of the total conductivity. And if you make an AC impedance spectrum, if you use an AC machine here, the interpretation of that spectrum may take some experience. On the other hand, if you do a through-plane measurement, the nice thing about that is that if you do impedance spectroscopy or AC conductivity, you can delineate the electrodes impedance from the bulk impedance by just deconvoluting the impedance spectrum. So that is nice. But on the other hand, you will have a very high conductance because the membrane is very thin in this direction and the electrode is big. So you get a challenge in collecting the current properly through the in-plane conductivity of the electrodes. And you also have to make the electrodes properly in order to measure like this. To show you some of these things in a set of example measurements on a NAF-ion film made in a ProboStat using this head. I show you results for a NAF-ion N115 film, which was 0.125 millimeters thick. It had an area of 18 times 18 millimeters. And we measured that at normal humidity by bubbling the gas through water. So this was 80% relative humidity at room temperature. We used 4 platinum wire electrodes in this head, and we used a Nova Control Alpha and a SET-G4 interface to do the measurement. So here you see an impedance spectrum taken at room temperature. You can see the bulk resistance that we're interested in. And you also see parasitic electrode impedance traces here that in principle should not be there because it's a 4 electrode measurement, but you get this when you do impedance spectroscopy on a 4 electrode measurement. Here you see measurements at the different temperatures. You see at 80 degrees, you see a small semicircle, and at 100 degrees, you see a bigger semicircle, and it increases with increasing temperature because that's how polymers behave. But the point here is that these semicircles are just artifacts. It is the DC value here, which is the real resistance that you need to extract. And these can then be converted to conductivity by taking the geometry into account. That is the film thickness, the distance between the voltage probes, and the current path width. And then we can calculate for different temperatures the conductivity of the film, going down with increasing temperature on this inverse scale, which is how polymers behave, because the relative humidity goes down when the temperature goes up, and the mobility of the charge carriers decrease. Here we measured up to 160 degrees on this head. And that was a small introduction to this new PEM head for ProboStat. If you have questions or comments on or inquiries on this, they are more than welcome to me or to Modex. Thank you.